Hello everybody, this is Sky Darmus, now filming from Germany. Recently I've started doing freefall experiments again with lead and zinc. Zinc is better than iron because we can be sure that the iron inside won't interfere with this magnet, won't change the amount of magnetism of the two vending machine balls. They both have equal sized washers on them. And before I was, I had a big sphere of lead inside, which was hard to center here because there's a plastic knob, and using many smaller lead spheres is better, more evenly distributed. And this here is the zinc sphere. The last try was very perfect. Very small standard deviations. In fact, the standard deviations were so small that they were not overlapping, which is the ideal case. Difference was about 0.4 milliseconds, and 0.3 is what is predicted for this height of about 2 meters from one laser gate to the other. Okay, let's get started. In order to be sure that the difference in freefall time is not because of mass, we have to make sure that the zinc filled sphere, which is predicted to fall slightly faster, is actually a bit lighter. So this is 929 and this is 939, so yeah, it's lighter. So but we will record the results here, it's faster. And we will get the average right away. So, but those very ideal tries were only obtained by attaching the masses extremely carefully and very centered. So we have to make sure that it's centered here too. 2 gates. Okay, zinc 5975. 5975. Yes, okay. Be careful to not touch anything. So bad if anything gets displaced even a little bit, that would influence the free fall time. This lead should be slower, and it is slower, 5978, exactly to the predicted amount. Exactly 3 milliseconds as predicted. Now again, zinc has more nuclear binding energy, and that reduces the mass but not the number of particles, and then you have more particles per kilogram, and according to my theory that means you have more gravity per kilogram. So that's how it works. gravity is proportional to particle count and not to mass or energy. Well, mass is just a form of energy. But in my theory, gravity is not proportional to energy. But in free fall, we're dealing with balance between kinetic energy and gravitational energy. So that's why the gravity per kilogram is very important here. Determines the value of small g. Okay, this is lead. Should be slower. 5979. Indeed, it is slower. This time the difference is larger than predicted, but that's fine. Some small deviations are quite normal and to be expected, but they shouldn't be too big. Now again, zinc. Zinc is faster, almost as fast as iron. 5975. 5975. And we can also see the time difference here. 4.5 is actually 0.45 milliseconds. And the standard deviations are still small for lead, but a bit too big for zinc. Well, it's always an option to rule out outliers if it's done in a symmetric way. But that's messy and I don't usually do that. It's also not as satisfying as including all results. Yeah. Okay, so that is lead should be slower. 5978. I mean, if let's say we did all the trials and there was one number which jumped out, let's say that's the smallest, one would be legitimate to remove it if we then also remove the simultaneous value of lead. And maybe supplement another additional pair of trials. So again, zinc. Is it centered? Yes. Zinc is faster. 5976. We see that the standard deviations have not become much smaller. But the time difference is getting closer to 3, which is the predicted difference. I wish this room was a bit taller, then the height would be greater and it would be easier for the standard deviations to be separated. This one is lead. should fall slower, and indeed it does. 5977. So we see that in each case the number for lead is larger in every single case. So we're going to do 10 trials. Be careful to not touch the photo gate, otherwise the distances may change. Okay, should be careful. Is it centered? Could be a bit more centered, yeah. Okay, zinc falls faster. 5975. Okay, we're getting very close to the number 3 here, which is predicted. And you know that's the number I predict because when I was doing these experiments in Hong Kong, I was predicting the same number, and the height was also approximately the same, 2 meters. Okay, lead, which is slower. Five nine seven six. Okay, in this case it was only very slightly slower. Now the time difference is exactly 0.3 milliseconds. The ratio between values of small g, the gravitational acceleration, is exactly the same as the ratios of the corresponding values of big G, which is the gravitational constant. So for zinc, that's something about, if you round it up, 6.674, almost, yeah. And for lead, it's I was very fast. And for lead, it's 6.668. Yeah, so they have quite a considerable difference in their G values. Of course, both big G and small g, but small g doesn't make much sense to write it down in numbers because it's different in every location on Earth. Hey, lead, the slow one. Okay, very slow, 5978. 5978. Normally I would finish 10 trials in a shorter time, like 10 or 12 minutes, but if we want small standard deviations, we have to make sure that the test masses are very well centered. This is zinc again, falls fast. 5973. 59. Oh, sorry, that's zinc. Okay, 5973. And now again, lead. I got these lead spheres from some fishing equipment shops. I think this particular one from Hong Kong. Some others I got from Greece. Okay, lead now. This is slowest 5981. Okay, now we are back up at 0.4 milliseconds. Sometimes I'm afraid that the observer effect might influence the free fall time. Okay, this one, zinc. Okay, 5974. Okay, so lead again. Okay, very slow, 5979. 5979. Two more trials. I think I slightly touched the cable there. Hope it's still in the same position. Oops. Is it centered? Yes. Okay, now zinc again. Okay, 5973. 5973. Seems no distances were changed. Everything is as it was. Oh, 17 minutes already. I'm spending a lot of time on this. Hope I'm not boring you to death. But well, this is scientifically very significant, so you should not be bored. This lead again is slower. 5979. 5979. Okay, now the time difference is at 0.4 milliseconds. Now that's just because these standard deviations have become slightly larger. Okay, not quite centered yet. This is good enough. Zinc again, the fast one. 5976. Okay, oh, I touched the cable slightly again. Oh, nothing is displaced. Nothing is displaced. Okay, the last trial. Okay. Lead again. 5980. Okay, so the time difference is 0.4 milliseconds. And the standard deviations are pretty small. Oh wow, oh my god. This means the standard deviations are not overlapping. You see here, this is a huge breakthrough. I mean, I did this already the last time, but now I repeated it on camera. Last time it was not on camera, so I'm very happy about that. Okay, I hope you enjoyed it. See you next time. Bye-bye.